If you want to run an AI model on your own computer, privately, offline, you basically can't avoid one piece of software. And most people who rely on it have never heard its name. It's called Llama.cpp. Nearly every app you might reach for, Ollama, LM Studio, the rest, is really just a wrapper around it. Take Ollama, by far the most popular way people run models at home, a YC-backed startup with a huge following. A while back, it tried to cut the cord. It announced its own engine and said it was moving off Llama.cpp. It couldn't. That engine still reaches back into Llama.cpp for the hard parts, the fast GPU code and the steady stream of new models it can't yet handle on its own. Llama.cpp's creator caught them at it and ribbed them for it in public. So if even Ollama can't get out, what makes this thing so hard to replace? Because turning a downloaded model into a working chatbot or an agent that actually does things for you is a stack of hard problems, and Llama.cpp solves every one of them. Start at the bottom. A model is just billions of numbers, and running it means multiplying those numbers together fast on whatever chip you happen to own. A laptop processor, an NVIDIA card, an Apple chip, an AMD one. Each one speaks its own language, so each needs its own handwritten code to run fast. That bottom layer, the raw math ported to every kind of hardware, is a library called ggml. And because the numbers are huge, you also have to squeeze them down small enough to fit on your machine at all. That's quantization, and it's enough of a rabbit hole that we gave its own video. On top of the math sits everything that turns it into something you can actually use. And this is where it gets fiddly. Start with this. The model doesn't read letters. It reads tokens, chunks of text it learned during training, and Llama.cpp has to slice your words into exactly the same chunks the model expects. Get it badly wrong and you get nonsense. But that you'd catch. The real trap is getting it almost right. The tokens come out close to what the model trained on, but not exactly, and quality slips. No crash, no error, nothing to tell you why. Then there's the format. Every model family wraps your message in its own special markup. Little tags marking where the instructions end and your turn begins. One model wants your text bracketed in inst tags. The next wants its own user and assistant tokens in an exact spot. Get that wrapping wrong, and the model doesn't crash, it just gets worse. A common failure, it carries on writing both halves of the conversation itself, because without the right markers, it never gets the cue that it's your turn to talk. It's harsher for agents. When a model reaches for a tool, runs a search, edits a file, it has to format that call its own specific way too. Get that wrong, and you don't get a worse answer, you get a broken one. A tool call no one can read, and the agent just stalls. Llama.cpp has to nail the exact format for every model, or none of it holds together. Then there's the conversation itself. As your chat, or an agent's long chain of steps, gets longer, the model would have to reread the entire history to produce each new word, which gets painfully slow. So instead, it keeps a running cache of everything it's already worked out about the history so far. That cache is the trick that keeps it fast. The catch is it grows with every word, and on a long enough history, it balloons. Run a small model with a big enough conversation, and that cache can eat more of your RAM than the model's own weights do. Deciding where it lives and when to throw it away is one more thing Llama.cpp handles. And the model never actually picks a word. What it hands back, every step, is a probability spread over every possible next token. Tens of thousands of them. Picture it partway through a sentence. The old house was, and it needs the next word. Maybe 30% on empty, 15% on quiet, a bit on haunted, and a long tail of everything else. Something has to turn that into one actual word. Always take the single likeliest one, and the model comes out stiff and repetitive. Let it sometimes reach for a less likely option, and it loosens up, gets more creative. That dial, how far it's allowed to stray from the safest pick, is called temperature, and it's a big part of what gives a model its feel. There's even a trick to make it faster called speculative decoding. When the big model produces one word, almost all the time goes into hauling its billions of numbers out of memory. The actual math is quick. And here's the key. Once you've paid to load all those numbers, checking a whole handful of words costs barely more than checking one. So you run a tiny, fast model next to the big one to guess the next few words, and the big one verifies the entire batch in a single pass. When the guesses hold up, and for easy words they usually do, you get several words for the price of one. Roughly double the speed, identical output. Newer models even do a version of this themselves, predicting a few tokens ahead. That's the MTP, multi-token prediction, you'll see thrown around. Hardware, tokenizing, chat formats, memory, choosing words, the speed tricks, that's the real job of running a model, and it's a lot. Now you can see why nobody rewrites it. Llama.cpp does all of it in one program with no dependencies that runs on basically anything. When the hard part is already solved and free, you don't redo it. You build on top. Even Hugging Face builds on it. Hugging Face is the hub where nearly all of these open models get downloaded from, and earlier this year, the team behind Llama.cpp joined them. They'd already been collaborating closely. This just made it official. Hugging Face's word for the deal? A match made in heaven. They host the models, Llama.cpp runs them. The project stays open source, the team keeps full control, and now the place you download a model and the thing that runs it are lining up into one path. The biggest name in open source AI didn't build its own local engine, it brought in Llama.cpp. That universality leaves room, though, for a few projects that make a different bet. Each one throws out a rule Llama.cpp lives by to win at something specific. Take MLX. Llama.cpp's whole identity is running everywhere, which means it can never tune too hard for any one chip. Apple threw that rule out. MLX is a separate engine that runs only on Apple hardware, so it can optimize in ways Llama.cpp can't afford to. The payoff is real, but narrow. It's faster mostly at the part where it reads through your prompt, mostly on smaller models. The price is it only runs on Apple, and it's always a step behind on new models. A sharper tool for one bench. Then there's ikllama.cpp, a fork by the same person who wrote Llama.cpp's compression in the first place, now off running his own thing. His bet is on squeezing even more aggressive compression, plus a trick for the very biggest models. The largest ones only use a small slice of themselves for any given word, so you can keep the busy parts on your fast graphics card and park the rest in ordinary memory. That's how people run a model that should need a data center on a beefed-up desktop. If you're cramming something enormous onto a modest machine, that's the tool. And the most extreme bet, a project called DS4, it throws out the biggest rule of all, running more than one model. DS4 runs exactly one, DeepSeek's big one, and nothing else. The pitch is that everyone else chases every new release and ends up supporting all of them half well. So instead, you take a single model and make it, the author's phrase, finished end to end. Hardwire its quirks, hand-tune its compression, and beat the general engine at that one thing. People run it as the brain behind a local coding assistant, and even built from scratch, it still goes out of its way to credit Llama.cpp. So that's what's under the hood. What you actually install on top of it is a much smaller decision. If you're on a Mac and you just want it to work, try LlamaBarn, a tiny menu bar app from the Llama.cpp team themselves. One homebrew command and it's running. It shows you only the models that'll actually fit your machine, you click one to download, and a few seconds later you're chatting with it in a browser tab. It also runs a local API, so you can point a coding agent or any other tool at the very same model. For most people, that's the whole job. Want to go further? A model the catalog doesn't carry yet, custom settings, hands fully in it? Go straight to llama.cpp. It runs everywhere. One line via Winget on Windows or Homebrew on Mac. But it's a command line tool, so you're in a terminal. Not into that? Not on a Mac? Or just want a friendlier, fuller app? You've got real options, and they're not interchangeable. Ollama is the popular default. It mostly just works, and it's easy to point a coding agent at. LM Studio is the polished closed-source app for browsing and comparing models by clicking. Jan is the open-source desktop app for keeping the whole stack open, and KoboldCpp is the fiction and roleplay crowd's pick. However you start, The best part is that it's all running on your own machine. A real model on a laptop, an old phone, a Raspberry Pi sipping 8 watts. Links to all the apps I mentioned are in the description. So pick one, put a model on your own hardware, and try it on something real. And let me know how it goes, especially if it ends up doing something useful for you.